Here we go, guys, an explanation of worksheet 5.7 WSP. On this worksheet, or on this homework, we're supposed to do numbers 2 through 6, 11 through 16, and 17 through 19. Number 2, we're going to begin by, again, forcing this to look like a quadratic equation, okay? So if this were a x squared minus 5x plus 4, you'd be able to factor it, right? So we're going to pretend that if we're an x squared plus 5x plus 4, and we think what times what is the last number 4, that if you combine together is a middle number, negative 5, and that would of course be a negative 1 times negative 4. That'll give you a positive 4, and if you combine those together, it'll give you the middle term, negative 5. Now, again, we're pretending that this were an x squared minus 5x plus 4. And if it were an x squared, then you'd put an x right here and an x right there. But because it's an x to the 4th, we're going to put an x squared right here and an x squared right there. Again, the only time you could actually do this where you pretend it's a quadratic is if your degree, the highest power, is twice as big as the power of the middle term. Okay, so we have this new factored form. It's still equal to 0. And you want to continue factoring. And this guy right here is x squared minus 1, which means you could think what times what is the negative 1 that if you combine together is a middle value, which is nothing. So that means you could factor it further, getting a plus 1, plus 1 and minus 1. And this one over here, x squared minus 4, same concept, you could factor it further. What times what is negative 4? That if you combine together is the middle term, which there is no middle term, which is 0. So it'd be a plus 2 minus 2. And of course, all of this is still set equal to 0. So what you really have here is this binomial times that binomial times that binomial times that binomial equals 0. We're going to use the zero product property to split them and solve. As you can see, I've split them all, set them all equal to 0, which gives us our 4 answers. X equals negative 1, x equals positive 1, x equals negative 2, x equals positive 2, if you solve each of those simple one-step equations. Another way you might see this on a multiple choice answer is that x equals plus or minus 1. That really means plus or minus 1, right? Or you could see it as x equals plus or minus 2. There's a positive 2, there's a negative 2. So the plus or minus is just a quicker way of writing your answer. Let's jump to the next one, number 3. Actually, we're going to skip number 3 because this was on the previous video on the notes. We actually did this one where you factor out the GCF and then you continue factoring. So skipping that one, go into this one right here. Now we have 4 terms here and it's cubic, so a lot of us might get confused, but we did have factoring by grouping, which was a tool in our factoring toolbox. And let's do that. Let's separate the first group from the second group, the first 2 terms from the second 2 terms. And after that, you factor the GCF out of the first group, which is a total of x squared, there's 2 x's. And what would be left on the inside? You'd have a x plus 1. Of course, x squared times x gets you back to there. X squared times 1 gets you back to there. Let's go to the second group and factor out a negative 3. So let's pull out a negative 3. And what would be left? X plus 1 as well. Now we're really happy that both of these binomials are exactly the same. If they weren't the same, we wouldn't be able to continue factoring by grouping, but they are the same. So now I need to do my exaggerated parentheses. I want to take the binomial x plus 1 that's in common in both the first group and the second group and pull it out of the whole thing, thus leaving us the x squared and the minus 3. And of course, I leave these exaggerated parentheses, I leave this space right here and this space right there, so you could notice that these are no longer right there. They got pulled out to the front. So that's what factoring by grouping is. Let me rewrite this with the correct size parentheses. We have x plus 1, x squared minus 3. And of course, this still equals 0. This equals 0 over here. Just bring it down. All I've done is rewritten this cubic polynomial as a binomial times a binomial. It's the same exact math, right? Same exact expression. It's just this is in factored form. In other words, up here, it was adding, subtracting, and subtracting. Now we have something times something, and that's really good because when you have something times something equals 0, then you could use the zero product property to split it and solve. So I am going to set x plus 1 set equal to 0. which is going to give me the answer x equals -1. Okay, that's one answer to the cubic equation. The other one is x squared minus 3 equals 0. So we're going to add 3 to both sides, giving us x squared equals 3. Then you apply a square root and a square root, giving us the answer x equals, when you apply a square root, you have to put a plus or minus in front of your answer. And the square root of 3 is a crazy decimal, but we just leave it as a square root of 3. Okay, so we technically have 3 answers for this cubic equation. 3 answers. One answer is -1, the other one's positive square root of 3, the other one's a negative square root of 3, which are irrational decimals. They're crazy decimals, but they are decimals, they are numbers, they are real. So this cubic equation has 3 real zeros, or 3 real roots, or 3 real solutions. Let's jump to number 5. Okay, so this one is a cubic trinomial. We can't even pretend it's a quadratic because we have this 3 and this is not half of 3. To be honest with you, as I look at this problem, I don't know what to do. I don't have any tools in my factoring toolbox that will allow me to factor this, so I'm kind of stuck. I could go with the rational root theorem and make a list of my possible answers by thinking of all the multiples of c over a, and of course a is 1, so that's really easy. Just make a list of the multiples of 20, both plus and minus. But that is a large list. We have 1, we have 2, we have 4, we have 5, we have 10. So that's a large list of the numbers, and also all the negatives, -1, -2, -4, -5, -10. So that's too long of a list of possible answers for me to start guessing and checking. So what I'm going to do is I'm going to actually go to Desmos and I'm going to graph this thing. So here I am at Desmos, and as a matter of fact, this is one question that we did do. I just recognized it by looking at the picture of the graph. We did this on the previous video. So we do have, I typed it in, x to the third, and of course you use your keypad down here. There's your variable x. If you want to type a power, just hit that button and then type in the 3. And of course you have your numbers over here and your math symbols. So you won't even see the entire graph unless you zoom out of this thing. Then you could see the snake-like curve. But what really matters is this point of intersection, because the point of intersection is truly our x-intercept, which means it's our solution. So x equals -2. So whenever you're stuck, or always have your Desmos app available to you, or a graphing calculator available to you, because that'll automatically tell you what one of the solutions is. Okay, so it would have been frustrating to start testing and it doesn't work, testing and it doesn't work. This is the first one that works, and that's the only one that works actually. Okay, so what we're going to do is use that answer, -2. Then we're going to make a list of the coefficients. We have 1 as a coefficient of x to the third. We have 0 as a coefficient of x squared, 6 as a coefficient of x, and 20 as the constant at the very end. So as you go down, you combine 1 plus 0 is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, you combine. 0 plus -2 is -2. As you go up, you multiply. -2 times -2 is +4. As you go down, you combine. 6 plus 4 is 10. As you go up, you multiply. -2 times 10 is -20. There is no surprise, guys, that the remainder is 0, because we saw on the graphing calculator, or on the Desmos app, that the answer, the x-intercept, is -2. Of course, x is -2. So I plugged it in. Of course, my remainder has to be 0. So why did I do this? So I could get my depressed polynomial, which will be a quadratic trinomial, right? This is your constant. This is x. This is x squared. So what we really have here is x squared minus 2x plus 10. And this, when you try to factor it, you cannot. I mean, that would have been nice if you could, but you cannot. So we will have to use the quadratic formula, where your a value is 1, your b value is -2, and your c value is 10. So x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. When you use it, please use parentheses. It'll be safer for you to plug in. So your b value is -2, your a value is 1, and your c value is 10. Okay, as you do this math, you're going to have -2 squared, that's +4. I'm just going to write it down here, +4. And then we have 4 times 1 times 10, that's 40. So you have 4 minus 40, which is really negative 36. So that's what belongs inside the square root. Let me rewrite it over here. We have a positive 2. I say positive because the minus negative right here changes to plus positive. So you have a positive 2 plus or minus the square root of negative 36. Maybe I shouldn't have made that square root that long. All divided by 2 times 1, which is 2. So all divided by 2. Now, the square root of negative 36, that becomes 6i. So we have 2 plus or minus 6i over 2. And all of these could be reduced by 2, okay? Or you could split them and reduce. So if you want to split them and reduce, you could just say, okay, 2 over 2 plus or minus 6 over 2 with an I on the side. Thus giving us a final answer. 2 over 2 is 1 and 6 over 2 is 3. We have a plus or minus 3 with an I. So this is our final answer on this quadratic equation. Or you could have just reduced 2, 2, and 6 all by 2, and it'll give you that same answer, 1 plus or minus 3i. So zooming out, let's look at all of our answers to this cubic. One answer was the x-intercept that we found, which was x equals negative 2. That's one answer. The other two answers are x equals 1 plus or minus 3i, which are imaginary. So in this case, we have one real answer and two imaginary answers. And that makes total sense because the degree is 3. Okay, so whenever your degree is 3, whatever your degree is, that's the maximum amount of answers that you could get. Now, sometimes they might all be real. Sometimes only one is real, 2 imaginary. Right here, we have 1 real, 2 imaginary. But it all depends, right? A 5th degree, you could have maybe 4 imaginary and 1 real. I don't know. Or maybe 2 real and 3 imaginary. It all depends. Let's move on. So this one looks pretty confusing. It's a 4th degree polynomial. I really can't see any factoring tools in my factoring toolbox that'll allow me to rewrite this in factored form. So I'm just going to jump right into Desmos. So as you can see, I typed it in. You could put y equals or f of x equals, or you could just type in the x to the 4th minus all that stuff, and you'll get the graph, and it will show that it crosses at negative 1, 0 and at 2, 0, thus giving us two answers, x equals negative 1 and x equals positive 2. So we know that both of those are answers. I'm sorry about that. We know both of those are answers. So let's go back over here. We know that negative 1 and positive 2 are answers. Let me write that down. X equals negative 1, that's one answer. X equals positive 2, that's another answer. And let's use these answers to get depressed polynomials so we could continue to factor and solve to find the other answers. It is likely that we have two imaginary answers because it's a 4th degree polynomial, and so far we have two answers. But then again, maybe let's just work. Here we go. So let me plug in the first answer, negative 1, right, in the box, and let me do the coefficients. 1 on x to the 4th, negative 1 on x to the 3rd, negative 1 on x squared, negative 1 on x, and negative 2 as the constant. As you bring down the 1, you combine 1 plus 0 is 1. As you go up, you multiply. Negative 1 times 1 is negative 1. As you come down, you combine. Negative 1 and negative 1 is negative 2. As you go up, you multiply. That becomes positive 2. As you go down, you combine negative 1 and 2. That gives us positive 1. As you go up, you multiply. Negative 1 times 1. Negative 1 times 1 is negative 1. As you come down, you combine. Negative 1 and negative 1 is negative 2. As you go up, you multiply. Negative 1 times negative 2 is positive 2. And no surprise, the remainder is 0. Why is that not a surprise? Because I already knew that the remainder has to be 0 if one of my solutions is x equals negative 1. And we know it's a solution because we saw the graph and we saw that it crosses the x-axis at negative 1. So we have this depressed polynomial, but I'm not even going to write it out because this is the constant, this is x squared, this is x to the 3rd. And yeah, we probably could write this out and then factor by grouping, but we already know another answer, 2. So let me just do the 2, and let me use the coefficients of the depressed polynomial, the 1, the negative 2, the 1, and the negative 2. All I did was bring them down, okay? And we're going to do this again. We are going to, of course, we're going to get the remainder of 0 again. So here we go. 1 plus 0 is 1. 2 times 1 is 2. Negative 2 and positive 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. And 2 times 1 is 2. And of course, the remainder, once again, is 0. No surprise, because we already knew that this guy was an answer. Okay, so why did I do that? To get my depressed polynomial. My depressed polynomial will be 1x squared plus 0x plus 1. All right, so let's just write that out. 1x squared, I'm just going to put x squared. I'm not going to put the plus 0x. That means that there is no x, but I am going to put the plus 1. Now, what this means is that that is a factor of the original quartic polynomial up there, okay? So if I wanted to write it in factored form, it would be x plus 1 in parentheses, x minus 2 in parentheses, times x squared plus 1 in parentheses. And if you did multiply those three binomials, it would give you the original. But the whole purpose of factoring is to be able to get these answers, which we already got from the graph. So let's get this other answer by setting this equal to 0. Okay, setting this equal to 0. So I have x squared plus 1 equals 0. That would tell us that we have x squared equals negative 1, which means we need to apply a square root, which means x equals plus or minus I. So as previously mentioned, the other two answers were imaginary. Okay, so we had 1 real, 2 real, and 2 imaginary. Let's move on to the next one. Find all the zeros of each function. Well, let's just jump to Desmos. So when I type this into Desmos, type it in right there exactly the way it is. Make sure you type it in carefully, because if you put one number wrong, it's going to obviously give you the wrong answers. You're going to get this graph, and by the way, if you don't see the actual coordinates the way you see them here, go ahead and tap on this button, and tap on that point, and they should appear, the x-intercepts. So right here we see that this, I believe it was a 5th degree polynomial, has 3 real answers. It crosses the x-axis at negative 7, that's one answer. X equals negative 1.5, positive 1.5, that's another answer. And x equals 4. So we have 3 real answers. So we have, here are our answers. X equals negative 7, 1.5, or you could rewrite it as 3 halves. It might be a little easier to work with fractions, unless you're using a calculator. And then x equals 4. So what I'm going to do is use these answers to come up with oh, wait a minute. I'm sorry. If we have 3 answers, and it's a 3rd degree polynomial, I thought it was a 5th degree polynomial, but if it's a 3rd degree polynomial, then we know that the maximum amount of answers is 3. And how many answers do we have here? We have 1, 2, 3. So we are done. That's it. Woo! Love those. Now, I thought this was a 5. I originally thought it was a 5, which means that there were 2 missing answers. So I would have plug these in, get a depressed polynomial, and then maybe I could get a quadratic, which I could apply a quadratic formula, which then maybe it would have given us the 2 other imaginary answers if this was 5th degree. But because it's 3rd degree, that means we could only have a maximum of 3 answers, and we do have 3 answers. So that is it. So here is our exact equation typed in right there. And if you click on this button, this is a screenshot of it. So if you click on it, it will show you the coordinate 1, 0, which tells you that your x value is 1. So your answer is x equals 1. And that's the only place that this cubic equation crosses the x-axis. So we have 1 real answer. That means that we have 2 other answers that are imaginary. Okay? So let's go back and find those other 2 imaginary answers. So we know x equals 1 is an answer. Put a 1 right in there. And then you have your coefficients, 1, negative 3, positive 9, negative 7. As you go down, you combine. 1 plus 0 is 1. As you go up, you multiply. 1 times 1 is 1. As you go down, you combine. Negative 3 plus 1 is negative 2. As you go up, you multiply. 1 times negative 2 is negative 2. As you come down, you combine. 9 take away 2 is 7. As you go up, you multiply. 1 times 7 is 7. And no surprise, the remainder is 0. Why is that? Because this was an answer, x equals 1. We saw it as an x-intercept when we graphed it. So we know it's an answer. And we plugged it in to find this depressed polynomial, x squared minus 2x plus 7. So let's write that out. X squared minus 2x plus 7. And that right there, we need to think, could we factor it? And we can't. And that's why we only saw one nice answer. I have a quadratic equation here, which means I'm going to use a quadratic formula to give me the imaginary answers that I need to find, right? So we only had one answer according to the graph. We still need to use the quadratic formula to find the imaginary answers. So let's write it out. And when we use the formula, let's use parentheses. Let's identify our a value of 1, our b value of -2, and our c value of 7. So let's plug in the b value of -2 right there and right there. Plug in the a value of 1 right there and down there. And plug in the 7 over here. So when we do this math, the minus minus becomes plus. So we will have +2 plus or minus the square root of. And let's figure out what's inside the square root, which is the discriminant value. So we have -2 squared, that is +4. So we have, I'm going to write a +4 right there, and then 4 times 1 times 7, that's 28 with the minus sign. So 4 minus 28 is what's our discriminant value, which is going to give us a -24. So we have a -24 as the discriminant value, which obviously is going to produce imaginary values over 2. So what we need to do now is know how to simplify the square root of -24. You might be able to type it in or ask Siri, but here is the old school way of doing it. We know that the negative is going to become an I on the outside, so what we really need to worry about is simplifying square root of 24. And 24 is not a perfect square number, so you want to break it down with multiplication to get a perfect square number. You see, 12 times 2 is not going to cut it, but 4 times 6, that will be 24, and 4 is a perfect square, which means if we split it, we'll be able to do the square root of 4, which is 2. So what we really have is I times 2 times the square root of 6, which square root of 6 you can't simplify further. So what we really have, in place of this square root of -24, we have I times 2 times square root of 6. I'm going to write it as 2I square root of 6, all over 2, all over 2. So the easiest way to finish this answer is to simplify everything by 2. 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. So we really were going to have a 1 plus or minus 1I square root of 6. 1 plus or minus 1I, I don't need to put a 1, square root of 6. So there are your other two answers to this problem. Okay? So make sure that you get really comfortable with that Desmos app, because that will find you some real answers, and it'll help you find the other imaginary answers. So let's type this one into Desmos to find our real answers. So there it is, typed in, nice and neat, and we see that it does cross the x-axis at 3, 0, which means that x equals 3 is a solution to this problem. So x equals 3 is an answer. I did not see it cross any other locations on the x-axis, which means that the other two answers should be imaginary, okay? So let's find those other imaginary answers using this real answer, which was the x-intercept when we graphed it. So we're going to put 3 inside the box and put the coefficients 1, -7, 17, and -15. As you go down, you combine. 1 plus 0 is 1. As you go up, you multiply. 3 times 1 is 3. As you go down, you combine. That'll give you -4. As you go up, you multiply. 3 times -4 is -12. As you go down, you combine. That'll give you a 5. As you go up, you multiply. 3 times 5 is 15. No surprise, remainder is 0. It has to be 0. If it's not 0, you did something wrong, which means that you're going to go wrong from here. Okay, so make sure that that becomes a 0. Make sure it ends up a 0. That's the only way to verify that that's the right answer, which it should be because we saw it on the graph. That's the only way to get the correct coefficients to your now quadratic equation, the constant, the x, and the x squared. So what we really have here is x squared minus 4x plus 5. And this is not factorable. If you think what times what is 5, that if you combine together is -4, it doesn't work. So once again, we're going to zoom in, and we're going to use the quadratic formula. And once again, let's use parentheses. And let's identify our a value of 1, our b value of -4, and our c value of +5. So let's put our b value of -4 right there and right there, our a value of 1 right there and right there, and our c value of 5 right there. Working on the discriminant, right here, -4 squared, -4 times -4 is +16. So we're going to have 16 minus 4 times 1 times 5. So we really have 16 minus 20. Okay, that's a 16 minus 20. So what we really have inside the discriminant value is -4. So we have a +4 out here in the front. So let's write that down. +4 plus or minus the square root of negative 4. That's what we said we had in there. 16 take away 20 is negative 4. All divided by 2 times 1, which is 2. So let's change the square root of negative 4 to what it truly is, 2i. Okay, so we have 4 plus or minus 2i all over 2. And you could reduce all of this by 2, or you could split them and reduce later. So if you split them, you'll have you'll have x equals 4 over 2 plus or minus 2i over 2, which of course this divides to become 2 plus or minus, this cancels out, becomes 1. So you really have 2 plus or minus I. That's what x equals, 2 plus or minus I, which is 2 imaginary answers. So one answer is real, the answer 3, the other 2 are imaginary. Moving on, number 14. Of course, I could type this into Desmos and get some answers, but I could see that this looks like a quadratic trinomial, and I could treat it like if it were a quadratic trinomial because this degree is twice as big as the middle term's power. And I could see 49, and I know that 1 times 49 is 49, and if I add those together, it does give me 50. So I know this is a factorable quadratic trinomial. If it were a quadratic trinomial, it's a quartic trinomial, but we're going to pretend it's a quadratic, and we're going to factor it. And instead of x's, we have x squares right here. And again, what times what is 49? That if I combine together is 50. That'll be a plus 49, positive 49 times positive 1. That'll give us 49, and if you add it together, it does give us 50. So why would I factor it? Because if I'm trying to solve it, which means find the answers, or in this case, find the x-intercepts, you could split it and solve when you have something times something equals 0. Okay, so that's what we're doing. X squared plus 49 equals 0. X squared plus 1 equals 0. Oh wow, this is nice. Because when we solve this, subtract 49, you'll get x squared equals negative 49, which when you square root, you'll have x equaling a plus or minus 7i. And that's 2 imaginary answers. And you solve the other one, minus 1, you'll get x squared equals negative 1. And when you apply a square root, you'll get x equals plus or minus I, which is another 2 imaginary answers. Ladies and gentlemen, even if we would have graphed this, let me actually show you, you would end up with a totally blank graph. And notice I zoomed out. It's not 1, 2, 3, it's 0, 10, 20, 30. The graph, you won't be able to see it till way up here in the 40-somethings. So obviously it has both end behavior in quadrant 2 and quadrant 1, and it never crosses the x-axis. So if you try to graph it to find a real answer, there are no real answers. So this is one of those examples where it's absolutely necessary to know how to factor, right? And you got your 4 imaginary answers using your factoring tools from your factoring toolbox. So again, you have 4 imaginary answers, and that makes total sense because your degree is 4. In this case, there are no real answers. So on number 15, let me show you the graph of g of x. I safely typed it in, and here's my graph. And by looking at this graph, I already know that my answers are negative 4, negative 1, and positive 2. Those are my answers. Again, if you click on the buttons on your app itself, it'll show you the actual coordinate 2, 0, negative 1, 0, and negative 4, 0. So those are my answers, negative 4, negative 1, and 2. And this is a 4th degree function, which means that we need 4 answers, which means we might have 1 imaginary. I'm not really sure, or maybe, yeah, well, let's see what happens. Actually, no, let me explain something right now that we're on this special topic here. You see, this line crosses through at negative 4. That means the answer is negative 4. But this line, it doesn't cross through at negative 1. It touches at negative 1. Okay? And this one crosses through at 2. Now, there is a difference when you interpret the graph. When it crosses through, that means x equals negative 4. Now, when it touches, it means that x equals 1, but it has a duplicity, right? In other words, -1 is an answer more than one time. But if it crosses through, then it's just one answer, 2, okay? So I have my 3 answers. I'm looking for my 4th answer, okay? Let me show you what that 4th answer is going to be based on the fact that this one just touched. That means that there's a duplicity on the -1. That means that -1 is probably, no, it is an answer 2 times. So let me plug in -1 to verify that that one's correct. So I have a -1. I have the coefficient 1, 4, -3, -14, -8. As you go down, you combine. As you go up, you multiply. As you go down, you combine. As you go up, you multiply. As you go down, you combine. As you go up, you multiply. Let me know if I make a mistake, guys. As you go down, you combine. That is 8, -8. As you go up, you multiply. +8. And to no surprise, my remainder is 0. That's obvious because I saw on the graph that it crosses the x-axis at -1. Now, what I'm saying is, because it didn't actually cross through at -1, it just touched, it curved up and touched at -1, I'm willing to bet, I know that the answer will work again because the -1 comes up more than one time. So let me use the depressed coefficients 1, 3, -6, and 8. My bad, that's a -8. Anyhow, when we do this, just to prove that the -1 works, 1 comes down, multiply. 3 and -1 is 2, and then you multiply, it'll give you -2. As you come down, combine, -8. As you go up, multiply, +8. And like I said, -1 works a second time. So we have a 4th degree function, and when we graphed it, we only saw these 3 answers. And we now know that x equals -1 has a duplicity of 2. So that's a very important fact. Go back over here and take a look at our graph. What's the important fact? That whenever your graph, if it crosses, that means that it's probably just 1. Or I believe it could be any even amount of duplicities, right? I mean, odd amount of duplicities. It could be 1, it could happen 1 time. So x equals -4, it could only happen once or maybe 3 times. If you have a kind of like a parabola that touches, then we know that it has an even amount of times it could have a duplicity. So if you have if it just touches, then the answer -1 could happen more than once, okay? So on number 16, we're gonna graph it on the Desmos app, and here it is. And as you can see, we have 2 answers, x equals -2 and +2, okay? Now, speaking of duplicity, well, we'll go back and talk about duplicity of answers in a little bit, but right now, let's remember that our 2 answers are -2 and +2. So that kind of makes the rational root theorem obsolete. If you have Desmos or a graphing calculator, you could jump right into your actual answers. So I'm going to get x equals -2, and I'm gonna verify that it is correct. Even though I don't need to verify, what I'm really doing is plugging it in so I could get a depressed polynomial, okay? So let me do the leading coefficients of x to the 4th is 1, -6 on the x to the 3rd, +6 on the x squared, 24 on the x. It's an ugly 24. 24 on the x, and a -40 as the constant. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, you combine. -6 and -2 is -8. As you go up, you multiply. -2 times -8 is +16. As you go down, you combine. That's 24. Okay, I apologize. That's 22, not 24. 22 right there. Okay, so then we're going to multiply -2 times 22. That'll give us a -44. And as you come down, that will give you a positive -20. I'm sorry, -20. I am messing up a lot. And then as you go up, -2 times -20 is +40. And we do have a remainder of 0. So we do know, we already knew that x equals -2 is an answer, but we did it to be able to get a depressed polynomial. Now, this would still be a cubic polynomial, right? You have your constant x, x squared, and x to the third. I'm comfortable with x squares. So I would, now that I used this top one, I would use this next one with the new depressed coefficients. So I want to put 2 inside, and I want to bring down the 1, the -8, the positive 22, and the -20. And I am going to hopefully get the remainder of 0 again, if I do it right? Bring down the 1, and then 2 times 1 is 2. -8 and 2 is -6. 2 times -6 is -12. 22 and -12 is 10. And 2 times 10 is 20. And of course, remainder is 0, because we already knew, according to our graph, that x also equaled 2. So we have verified both. Even though we didn't need to verify, we know that the graphing calculator is not going to make a mistake. We know that x minus 2 is an answer, and we know that x equals 2 is an answer. But the reason why I did this is to get these depressed polynomials. And in this case, now I have a quadratic that I'm comfortable with. Constant x, x squared. I have x squared minus 6x plus 10. Let me write that over here on the side. X squared minus 6x plus 10. It would be nice if we could factor that, but we can't. We already know that because on the graph it doesn't cross at other nice locations. So this is a quadratic trinomial, and we would have to solve it because these will be likely to be imaginary answers. Let's see what happens. We're going to solve it with the quadratic formula. And when we use the quadratic formula, let's use parentheses when we plug in our values. And let's identify A is 1, B is -6, C is 10. So plugging in the -6 for B, the A value of 1 right there, and the 10 over here, we will end up with a positive 6 plus or minus. Now this is 36, but then I have -4 times 1 times 10, that's -40. So 36 minus 40, that would give us a -4 in there. Okay, all over 2. And this becomes 6 plus or minus 2i. Anytime you do a square root of a negative, it becomes I. Square root of 4 is 2. It's still over 2. And at this point, let's just reduce everything by 2. That becomes a 3, that becomes a 1, that becomes a 1. So your final answer, x equals, we said, becomes a 3 plus or minus a 1i. I'm just going to put I. Over 1, I'm not going to put over 1. There are my other two answers. So this 4th degree function on number 16, it actually has 4 answers. That makes total sense. 4th degree, 4 answers. We have one answer -2, another answer +2, and the other 2 answers are imaginary, 3 plus I and also 3 minus I. Jumping to the last section of the homework, it's where I give you answers and they want you to write polynomial functions. And I believe these were the examples that were done on the notes section. So if you need to watch those again, please go to the notes section and do those. Let's go through number 19 at least, all right? So we have these 3 answers, which are really 4 answers because of the complex conjugate theorem. Complex conjugate theorem says if you ever have a complex number, like, or an imaginary number, 3i, then there's also the complex conjugate that's the same, that's an answer, which is -3i, okay? So whenever you see an I, think the opposite value will also be a solution. Now, if they gave you that your answer was a binomial, like let's say 2 plus 3i, then another answer would be 2 minus 3i, okay? The complex conjugate is the answer as well. So right here we have 4 answers. Where did these answers come from? They came from x equals -1, x equals 4. Actually, these are the answers. X equals 3i and x equals -3i. Now, where did these answers come from? They came from a binomial that was set equal to 0. So that's what I'm going to do. I'm going to set them each equal to 0. I will have x plus 1, that equals 0. I'm going to subtract 4. I'd have x minus 4, that equal to 0. subtract 3i, subtract 3i. I'll have x minus 3i, that's set equal to 0, plus 3i, plus 3i, x plus 3i, that is equal to 0. So these are all set equal to 0, and we need to use the zero product property backwards, where instead of splitting them all and set them all equal to 0, which is what we have here, we're going to take these binomials and we're going to multiply them all together to get the actual nth degree equation that gives us these answers. I believe it's a 4th degree equation. So let's put all of them together. X plus 1 times x minus 4 times x minus 3i times x plus 3i. So it's best to begin with the i's, right? Let's distribute right there first. We have x times x, that's x squared. X times 3i is positive 3xi. Negative 3i times positive x is a negative 3xi or ix, whatever. And then negative 3 times positive 3, and both i's, that'll give you a negative 9, but I times I is I squared. Okay. Now the middle terms are exact opposites. They will cancel out. The I squared becomes negative 1. So what we really have is x squared, negative 9 times negative 1. That'll give you a positive 9. So this is what we get when we multiply the x minus 3i times the x plus 3i. And again, we want to multiply everything together. So we still have the x minus 4 and the x plus 1 that we need to multiply through. And it doesn't matter which way you go. You need to multiply all of them, right? So you could do these two binomials first or these two binomials first. It's totally up to you. I normally go with these, but just for the sake of showing you a different path to the same answer, I'm going to multiply x times x squared. That'll give me x to the third. X times 9, that's 9x. Negative 4 times x squared is negative 4x squared. Negative 4 times 9, that's negative 36. And this is the answer. I just need to put it in order. Well, it's not the answer. It's a cubic polynomial so far, but I need to put it in standard form. So I have x to the third minus 4x squared plus 9x minus 36. That's still technically in parentheses, and we still need to multiply the x plus 1 into it. Okay, so let's do that. Let's multiply the x plus 1 into it. Let's distribute. X times x to the third is x to the fourth. X times negative 4x squared is negative 4x to the third. X times 9x is 9x squared. X times negative 36 is negative 36x. Now here's where it gets a little more interesting. When I distribute the 1 times x to the third is positive x to the third, but instead of writing it over there on the side, I might as well start lining them up. Write it down here, plus x to the third, right below the other x to the third. That way we could cancel it out quickly. So I'm not going to write it over here on the side. I'm going to start lining them up already. So 1 times negative 4x squared is negative 4x squared, lining it up below the other x squared. 1 times 9x is 9x, lining it up below the other x. And 1 times minus 36 is minus 36. And now it's really easy to combine like terms because they're all lined up. So your final answer is x to the fourth minus 3x to the third plus 5x squared minus, what is that, 27x minus 36. Believe it or not, ladies and gentlemen, if you type in this 4th degree polynomial function into Desmos, it will give you two X-intercepts. X equals negative 1 and x equals 4. And of course, the other two will be imaginary. So this is already a ridiculously long video. I've covered all of the questions on the homework. No excuses, guys. You guys should be able to do it.